Hey guys, what's up? It's your boy Trix. Today we're going to be doing another Rust video. I was drinking some water, sorry about that. But yeah, we're going to do some more Rust exercises on Exercism and let's see how we go basically. So, yesterday we done bowling, binary search and all your bases. Today we're going to try .dsl, ETL and grade school. So let's get started. A domain-specific language is a small language optimized for a specific domain. Since a DSL is targeted, it can greatly impact productivity, understanding by allowing the writer to declare what they want rather than how. One problem area where they are applied are complex customization configurations. For example, .language allows you to write a textual description of a graph, which is then transformed into a picture by one of the graph viz tools, such as .a simple graph looks like this. Oh, so it's kind of like UML, where you have where you can specify in like plant UML through code how you want to draw a graph, if that makes sense. So let's just look at the shading things because we're cheating always. Okay, so this one has quite a bit of code. You know what? If the code is like this, I don't know if I want to do it. Edge. So implements edge, A, B, graph, self, and then with that new AP. Yep, you know what? We're gonna leave this one. Not doing .dsl today. We're going to do ETL. We are going to do transform step on extra transform load. If the code is immensely long, I don't see a point in doing it because then I don't believe I'll learn from it properly. Okay, so here we are. This one uses a binary tree map. Yep. And then this is the code for it. So let's try explaining this code. And B tree map char H. Hang on, let me just change what changed. I didn't even need to copy everything. I should just copy this, couldn't I? And then just change it from legacy to H. Okay, so H.iter. Okay, H. So on H, you want to iterate through each variable of H. So each element in the tree map or in the binary tree. Then you want to flatten the binary tree so that it's, instead of being a tree, you want it to be an array. Then you want to retrieve the score and letters. So this tree has a score, and I'm guessing an array of letters. This is just saying a vector object because in Rust, most data types like arrays, lists, trees, whatever, they're mostly vector objects. So this is just saying it's a vector object with characters inside of it. So this is just like a character array or character stack or character queue, something. It's just an object that has characters. Then you want to go through each character. You want to iterate through each character and move each. Oh wait, you want to iterate through each letter in the letters array, right? Because you have a characters array, right? So you want to iterate through each letter and move the character so that it's two lowercase with the score, and then collect all of them together again. So this just converts all of the characters to lowercase, I'm assuming. Yeah. I was assuming that the difficulty goes up alphabetically but it looks like the difficulty isn't going up alphabetically, but just in a random order. So that's great, isn't it? Let's try grade school. I'm hoping it's easy because grade school. It's looking okay-ish. Given students' names along with grades they are in, create a roster for their school. In the end, your school should be able to. Okay, I want to see what the code does. Solutions. Okay, so this is grabbing a binary tree map and a binary heap that we can use later. So let's grab this, chuck that in there. Then we're creating a... Okay, so this is inside of this struct. All we want to do is we want to have the grades in that school with the grade and the person's name. So like on the test, it has the grade and the person's name, right? So inside here, it will have... It will do... No, it will do self colon... Nah, school grades... Oh, okay, that makes sense. Hang on, I can still do this though, because you can just replace it with self. So all we're doing is we're defining that we want to return school, and because this is already school, we can just say self with grades with a new binary tree map. That should work. Test add test grade for empty school returns the students in, that's fine. And then in add, we're just doing this. Okay, so let me grab this and then try to explain it. So this gets the grades from this school object, then creates an entry for the grade, checks if there's an entry for the grade. If there isn't, you insert into the binary heap for that entry and push the student's name for that grade. And then we have grades. Okay, so all this is doing is... So basically, you can have multiple students' names here with the same grade, but only one grade for that student, if that makes sense. So it'll be many students to one grade, but one grade to many students, obviously. And then, so this just gets the grades attribute, retrieves the keys for the grades, so that would just be the scores, and collects them as a vector object. Because we're retrieving it from the binary tree, we don't want to retrieve it as a binary tree or like just the individual elements. We want to collect them together in their own object. So we're calling collect so that it creates a vector object to store all of those elements in. And because the scores are unsigned 32-bit integers, we return a vector object with unsigned 32-bit integers. And then the last one is grade. This, I'm just assuming, is getting the highest grade. List of students. So what does this do? So retrieves all of the grades from the school object, then gets the specified grade that we pass, clones the whole object that is returned from retrieving that grade. So it'll have the grade and all of the students that have that grade. Then we're creating a new binary heap to store all of the students' names that are associated with that grade. And we're sorting that vector object so that it's in alphabetical order for all of the students' names. Can I check that? This, yes, yeah. Without looking at the test, that was like very simple to understand just from looking at code. And then the last one is Hamming. Calculate the Hamming difference between two DNA strings. Okay, let's have a look at the solution. Solutions. Hang on. Okay, this one is misspaced out, so let's just take a look at this. Okay, so this gets the length of S1 and the length of S2, and if they're not the same, then you just want to return none. Because it says, as it says up here, return none if the lengths are mismatched, so they have to be at least the same length. Because you can't compare two DNA strings that are different lengths. That's somewhere in this. Then, if they are the same length, you want to actually calculate the distance between the characters. So, distance equals S1, so you take S1, and you convert the string to a character array. Then, you convert the string 2 to a character array. What does zip do in Rust? Rust zip. An iterator that iterates two other iterators simultaneously. Oh, so it'll iterate. So zip S2 chars will iterate through S1 and the S2 character array both at the same time, and all it will do is, okay, so the next one is filter, which takes the current character of S1 and S2 while you're iterating through it with zip, and checks if those characters are the same. If they're not the same, you count that, oh, this is this number, this is different. So like here, because it's only counting the ones that are different, you only check if they're not equal. So you count 1, 2, 3, 4, 5, 6, 7, because those characters are different. So you know that the differences are 7. And then all you do is return sum distance, with distance being the actual number of characters that are different. The Rust implementation looks a lot simpler than the one that's for Go. At least on my brain. But yeah, hang on, let's just check Hamming, grade school, and ETL. 1, 2, 3. Okay, that's it for the Rust video today. That was a very short video. Did not expect the code to be like very concise in that. But anyway, let me just switch back to this one. Thanks for watching. If you liked the video, please leave a like on the video. If you dislike the video, please leave a dislike on the video, and comment down below ways you want me to improve the content on the channel, so that I can make your viewing experience better, and so that my content on the channel can improve. I do want to do some more coding videos, some more programming videos, keyboard, anime, IEM, light novel, webtoon, that type of stuff. But I'd rather do content that you guys want to see and I might enjoy, than just doing content that I like and then no one watches it. But yeah, anyway, check out the links in the description to my other socials. My blog's down there. I have other socials down there too. I also have ways that you guys can support me if you want to. Other than that, subscribe to the channel. Enjoy the rest of your day. Peace.